Welcome back to the second part of the Stargate address system. And in the first part, we were strictly limiting ourselves with 2D, a 2D surface, polygon. Now what we're going to do is we're going to move into the three-dimensional area, or probably you could see it as multi-dimensional in all reality. Okay, so, but, first we figured out how to solve the solution for y1 and y2, okay? And now we're going to combine y1, y2, and the other set of coordinates here, okay? Okay, so this is the planes that I talked about before. And I'm just going to get to it, and I'm going to draw the different coordinates. Okay. Blue chalk. Okay, the first set of equations, the y1, y2, are going to be there's going to be one set on the horizontal plane. So I better label these. I better label these first. Okay, this plane right here, this plane, why don't we call that H? Okay, and this plane right here, I think I want to call that. This one. We're going to call that V for vertical plane. Of course, depending on your orientation to this diagram, depends on which one is horizontal, which one is vertical. Okay. So I'm going to write the first set of equations here, and just going to be like this. That's our y-axis, and then let's see, what do we have? We have over there, and we have like that. Okay, that's our first set. And like I said, that's going to be on the H plane right here. Part of it you can't see it because it's intersecting and so on. Okay, done with that. Okay, now let's take our yellow chalk here, and the next plane is going to be on the vertical plane here. Okay, and so it's going to be looking like a diagonal here. And so we've got so that's behind there. And then we have other part, which is just like that. Should be like that. Okay. Finish with that. All right. So it might be a little difficult to see, but you can see that there's there's the y and the z-axis usually form a cross like that on the regular 2D planar surface. But we have two sets of planes or planar surfaces. And so what's going to happen when we actually graph the equation is we're going to have one set of y1 and y2 on this plane, on the V plane, and another one on the H plane. And the combination of these two coordinates is going to be able to tell us exactly where in 3D space that our wormhole is going to exist at. Well, at least the B section. A would be where we're at now. B would be where we want to go. Okay, for example, if we got something like X, let's see, that would be the X plane. If we got something like right here, and then let's say go up on the vertical, Y here about 3, we have something like that. Then we go on the other one, let's see, we have something like, right here, And let's see, go up a little bit, and okay, be like that. This is just purely speculative, and just random arbitrary points on the different planes. Okay, now this plane right here would be on this point would be on this plane right here. Okay, it's like we take a piece of paper. We just take a piece of paper and draw a line on there, set it up in 3D space, and then take another one and put it perpendicular to it, and draw another line right there. And based on how we would perceive that with our stereoscopic vision, would be able to tell us where in 3D space that is. Okay. So if we want to look at this from an algebraic point of view, figure out all of our variables and everything like that. Okay, let's see. Let's just, for example, say on the vertical plane here is going to be our y1 and y2. Okay, on the horizontal plane over here, we're going to have our other set. And because those are kind of the diagonal axis, if you want to call it that. Of course, this is hyperspace physics, so we don't really have a z-axis as we would perceive it in our 3D world. But just just to make things a little more simple, I'm just going to call this z. So we have z1 and z2. Okay. Okay. So if we want to know where this wormhole is going to exist in 3D space, we need to find a solution between x1, z1 and z2, and then we need to find the solution between y1 and y2, and then, yeah, take a deep breath. We need to find the solution between the result of z1 and z2 and the result of y1 and y2, which is going to be, if you have to write this all out by hand, it's a mouthful. It's a brain full of stuff. And as you're going to see later, the equation that will explain all of this is simple, yet it has been expanded and developed to do everything that we need. Okay, so to summarize this up, imagine that we have two sets of simultaneous solutions of the equations of the line, linear equations. Each set, there's a set of two, each two lines are going to be on one plane of this. One set, the z's, are going to be on plane H, and the y's are going to be on plane V. And we are going to find out where exactly all four of these equations fit, where they all come together. And that point right there will be our destination point in our Stargate system or our wormhole system. Okay, and yeah, that's about it. No need to make it more complex than it really is for right now. As always, if you have any questions, send me some mail, hate mail. If I'm just crazy, let me know. I'm always laughing at something on the internet or something anywhere. Okay, let's see what else. Oh yeah, one thing, like for example, I was not very good at math in school unless I found an application of it, and then I could understand it. I have no idea how I figured out this math, just in my head somehow strange. But anyways, I've looked at a lot of different kind of, a bunch of different kind of coordinate graphing systems, and I can't really seem to find a system that kind of fits here. Obviously, this is not standard linear a 3D Cartesian coordinate system. It's definitely not radial. It's definitely not radial coordinates or anything like that. Um, or anything like that. So I'm sure probably somebody somewhere sometime used this kind of coordinate system somewhere, but I don't know where. I really don't know where. If you could tell me, I would really appreciate it, and I would really like to know more about this kind of coordinate system, this kind of math. Because I think it's very crucial that more people understand this in the future, especially because I'm pretty sure within the next 50 to 100 years we are going to be out there in space doing something, picking fights with somebody we probably shouldn't be or something like that. But anyway, yeah, it's good for us to learn this as soon as possible so we can start applying it to do whatever we feel we need to do. Okay, well, thanks for watching, and next time we are going to be getting into some more cool math. Cool because you can do some interesting stuff like this. Okay, and bye for now.